Let A be 2, 1, 0, 4, B be 6, negative 2, 2, 1. I want to compute A plus B squared. At this point, I don't want you to do this. It's not right. It's not right. All you have to do is what? You have to multiply out twice, right? But we're not gonna do that either. It's too long. It's not wrong, it's just long. Right? So what I'm going to do is, because AB have the same size, what can I do? I can add them first, right? So let's take A plus B first. And then we square it later, right? A plus B, 2, 1, 0, 4, plus 6, negative 2, 2, 1. 2 plus 6 is 8. 1 plus negative 2 is negative 1. 0 plus 2 is 2. 4 plus 1 is 5. Now, A plus B squared. Well, that's A plus B right here. So that means all you have to do is take matrix A, negative 1, 2, 5, and then you square it. Again, does not mean you distribute the 2 into each of those, right? You have to write it out twice and you multiply them. It's like that. Do not distribute 2. All right, matrix multiplication. First row, first column. 8 times 8. Oops. Plus negative 1 times 2. 8 times 8 is 64. Minus 2 is 62. So far, so good. Maybe I'll write it out. You guys look like you don't you heard for the first time. 8 times 8. Plus negative 1 times 2. Which is 62 there. First row, second column. Same thing, you multiply corresponding entry, you add them together. 8 times negative 1 plus negative 1 times 5. Negative 8, negative 5, that's negative 13. Second row, first column. Two times 8 plus 5 times 2. Dot product. 2 times 8, 16 plus 10 is 26. Two times negative 1 plus 5 times 5. 23. We're done. A plus B squared. You can check with your calculator. Thank you. Any question? It's a good time to ask. Today's lecture is very light. My goal is just finish this section, that's all. Yes. Hmm? And it's gonna be the same. Next one, well, you still have to finish this matrix, right? -1 plus negative. Same thing when you go to the second one. Finish, right? You're done. Now, second row, first column. 2 empty. Mike, can you mute yourself?
Yeah, my bad. I'm sorry.
Two times 8. 2 times 8 plus what? 5 times 2. And it's the same thing, right? This one with this column, 2 times -1 plus 5 times 5. I hope this answered your question. Okay. Why do we what? You okay with A plus B? What's my next step is what? A plus B squared, right? A plus B squared, what's A plus B? A plus B, you calculate it as what? At this matrix, that's A plus B, right? So you square that matrix. I say do not distribute 2. It doesn't mean you square each of these entries. What you have to do is what? Write out twice, just like x plus y squared, x plus y times x plus y.
I think the screen disconnected again.
Yeah, I know. It's only happened in this class though. My other classroom is fine. Come on. I apologize. Out of my control. All right. Matrix products. Rule for matrix products. Associative law. If I multiply AB first and then multiply C, it is the same thing as multiply B with C first and then multiply with A. Right? Make sure you put in the same order though. What you cannot do is this. What you cannot do is this. That's wrong, right? Why can't we change matrix like that? In order to multiply 2 matrices, what you have to have. why this not true? I know 3 times 2 is equal to 2 times 3 for real numbers, but in matrix it's not the case. Multiplication is not commutative. Why is that? In order to multiply 2 matrices, what do you have to have in the inner dimension?
Is it the same amount of rows and columns?
Yes, you have to have the same row and column. So for example, if A is 2 by 3 matrix and B is 3 by 4, A times B is okay, right? Why? Because you have 2 by 3 and then 3 by 4. Your inner matrix is matched. You okay? Right? But if you flip them around, B times A, now B is what? 3 by 4. A is 2 by 3. All of a sudden you can't, right? It's not the same thing, right? That's why matrix multiplication is not commutative. What I meant by that, for the law number 1, when you multiply AB first times C, you do the same thing over there. It's just different. The parentheses move. The only thing did not move is the order of each letter of each matrix. You cannot put A here, will be wrong. Might be wrong. Distributive law, matrix A times the sum of 2 matrices, you can distribute them by multiply. Distribute matrix A into each of those. Assume they have same inner dimension. Let's take a look at the example. Real estate, Bond Brothers. A real estate development build houses in 3 states. The projected number of units of each model to be built in each state is given by the matrix. So column is models, model 1, model 2, model 3, model 4, right? Row represents states. So for example, in New York, they build 60 houses that are model 1, right? 80 houses model 2, etc. The profit realized are 60,000, 67,081, and 95 for each model 1, 2, 3, 4 respectively when it's sold. Write the column matrix B represent the profit for each type of house. Write the column, and they want you to call that matrix B. It is a column matrix, so we're gonna have 1 column, right? Many rows, 1 column. For the profit of each type of a house, the profit is what? 60,000 there, 67, 71, and 95. That's it. That's all they want you to do. Part B, find the total profit Bond Brothers expected to earn in each state if all houses are sold. So this one is what? Dot products. Remember you did the Costco examples, right? But I don't want to do that again. I want to use math, it's faster. So you're gonna write out your, let me ask you, I have 2 matrix here, matrix A and matrix B. Should I write this matrix first and then put B next to it, or the other way around? Which one should I write first? This is 3 by 4, right? This is 4 by 1. So A come first, right? So A come first. 60, 80, 120, 40, 20, 30, 60, 10, 10, 15, 30, 5. 60,000 67,000, 71,000, 95,000. Use calculator. I'm not doing this by hand. Like I said, for the application problem, I'll never make you do by hand. 3 by 4, 4 by 1. Match.
Will we have to do this type of problem on the exam by hand?
No, not by hand. You can use calculator. I'll specify on the exam. Okay, I'll say which one you should show me work, which one you just use your calculator. You guys remember how to do this? Second matrix. Go over edit. Let me go back up. My matrix A is 3 by 4. 60, 80, 120, 40, 20, 30, 60, 10, 10, 15, 30, and 5. Second, make sure you press enter at the 5. Okay. Second, quit. Second matrix again. Go over edit. Now go down to B. B is 4 by 1. 60,000. 67,000. 71,000. And 95,000. Quit. Second matrix. You take A times B. So names, A first. And then second matrix, go down to B. Put your cursor down to B. Press enter. Enter one more time. That's your process. In each state, right? And it should make sense. Something big, right? Wow. So roughly, I'm just gonna write. I don't remember. So I just gonna approximately. Okay, so for New York State, roughly they earn 21 million. For Connecticut, 85 million. And Massachusetts is 4 million profit.
Wait, so we always have to put it in scientific notation?
You don't have to. I just didn't want to go back and forward between my iPad and my calculator, which is on the iPad.
Okay.
You can write the exact answer. Let me ask you a question. How many ways you be able to solve a system of equations so far? You just did on your quiz. So first one, Gauss-Jordan elimination, right? The matrix one, REF. The one before that is what? Method of elimination. Okay, so let me remind you. We go back to a few lecture. Last time we did this. Which is on your quiz. And I asked you to do REF. For those of you who did REF, you lose a point because I asked you just to do exactly what I asked you to do exactly what I did when I was in the class. So one way is you row reduce echelon form, right, which is this. RIF, which is this, the bad, nasty one. Of course, the calculator can do it very quick. That's how they do it. But for human, we just not liking it. But we have to know because you're going to see it again in linear algebra. The other method is method of elimination. Do you remember this? These one. Now I'm going to introduce you another one. Let me go back to my section 5.5. I know it's only one slide here. Another way to solve for x is by matrix representation. Matrix representation of a system of a linear equation is in this form. AX equal B, where A is your coefficient matrix. So for example, this example right here, A will be what? 1, -3, 1, 2, 1, -1, 1, -3, 1. This is the coefficient matrix because it's come from the coefficient of x, y, z times x, A times x. Notice that it's a big X. That's your variables, x, y, z. On your homework, sometimes they use x1, y, x2, x3 instead of x, y, z. The reason being because at some point, you're gonna run out of letter, right? But you don't run out of number. For the sake of simplicity, I use x, y, z. Equal the constant matrix. So x is, let me see, x is the what the book called the column variable, That's what you're trying to solve. And the last one is your constant matrix or constant column, which is one on the right side of the equal side. 1, 2, 3. So far, so good. That's just introduction. Right? If I give you a system of equations, you should be able to write in that form. What I'm going to do next, for next class, we're almost done. I need to solve for x, y, z. Now, you don't have to write this down. How do I solve for x? I divide both sides by 3. Or another way of saying divided by 3, I multiply both sides by what? Inverse of 3, which is 1/3, right? Can I write like that? Yes, the same thing is 3 or -1 is what? 1/3, right? And they cancel. Because 1/3, 3 cancel. Then you have x equal 2/3. The reason I introduce you this notation because in matrix, you can't divide two matrices together. You can't. You can't just say, don't write this down. You can't just divide everybody by that red matrix. There's no formula for that. You can multiply two matrices, though. Cannot divide two matrices. That's why we have to come up with what? Inverse, right? So in order to solve for the x, y, z, in order to solve for x, what I'm going to do is I'm going to do what? I'm going to multiply both sides by A inverse, just like I did with 3 inverse, right? Make sure you put it in this. If you put A inverse on the left, here, you should do the same thing over there as well. Remember what I explained, matrix is not commutative. A and A inverse cancel, that's just give you what? The identity matrix, right? Maybe I should have write like this. Those two right there give me I times X equal A inverse times B. What I times X equal? X, right? Remember what I said, the matrix, let me go back up here. Right there, A times I equal A, I times. So X equal A inverse of B. And you know how to calculate A inverse B? Plug in your calculator. There you have X, right? A is what? A is 3 by 3. B is 3 by 1. So your answer X would be what? 3 by 1, right? 3 by 1 right there. So that will be your little x, that will be your little y, that will be your little z. Does that make sense? That's the whole picture. Let me give you an example. Don't write that down, just scratch. Just explain things to you. Or you can continue with the example that we just had. We don't have to make up a new one. Then we call that a day. I want to solve for that. So what I'm going to do is I'm going to multiply both sides by, let me copy that thing down. Give a little space there. 1, -3, 1, 2, 1, -1, 1, -3, 1. X, Y, Z equal, leave a little space. 1, 2, 3. I need to get rid of the red matrix, which is, remember this is what? This is A, right? That's A. So I have to multiply both sides by what? A inverse. So 1, -3, 1, 2, 1, -1, 1, -3, 1. But inverse. Notice that I have a little -1 up here, indicate inverse. And I'm doing the same thing for the right hand side as well, so that I don't change my equation. Is there any questions so far? It's a good place to ask, yes. Oh, 1, 2, 1, sorry, thank you. Was you guys tried to talk? It's just, thank you very much. Just go with the roll. I gotta roll with the ball. 1, 2, 3, thank you. 1, 2, 1. But so far so good. Yeah. All I was just said is just applying the inverse property. A inverse and A cancel. You put in your calculator, it give you an identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. Which is times with X, Y, Z is gonna give you X, Y, Z as well. And your answer is this. 1, -3, 1, 2, 1, -1, 1, -3, 1, times 1, 2, 1. It's inversed here. Forgot about that. And you plug in your calculator?
What's that bottom row on the answer? The bottom row.
One.
I mean row 3.
-3,
It says
1.
Okay, I couldn't see the -3.
No, for some reason it didn't save. Thank you though. And you plug in your calculator, it'll give you some number, right? Give you your XYZ. Let's maybe we can do this together. Take the picture so I don't have to go back and forth. Second matrix, edit. Matrix A is a 3 by 3, my coefficient matrix. One, sorry, 3 by 3. 1, -3, 1, 2, 1, -1, 1, -3, 1. Quit. Second matrix again, over edit, go down to B. B is the 3 by 1. 1, 2, 1. So you enter the 2 matrix in, quit. Go back to second matrix again, names. A, press enter. I don't want A, I want A inverse. Do you see anywhere that you can press the inverse button? So once you have A, just press the X inverse button. You turn A into A inverse. And then second matrix, go down, put the cursor down to B, enter again. There's your solution, 1/2, 0, 0. That's XYZ. Now, I'm giving you the whole picture first. Later on, I'm going to show you how to calculate A inverse by hand. I have to, I'm sorry. I know I wish I just show you the thing, but I have to, for the sake of your final. On your exam, I'll never make you do that, I promise. Not by hand. But for the final, they might make you do that, okay? So that's the whole picture. The A inverse, the purpose of the A inverse is to solve system equation, okay, by matrix representation. Next class, we're gonna go into detail how to derive A inverse by hand as opposed to use calculator, okay? Anything else? If not, we adjourn today. Like I said, I'm just trying to finish 5.5. Have a wonderful weekend and I'll see you Monday.